I'm Tori Kentner, and I work for the Mid-Atlantic Fishery Management Council. I'm going to give you a short walkthrough of the Essential Fish Habitat Designation demo app, and in the next few minutes I'll show you how to navigate the app, explain the layers you can view, and also walk through how the proposed EFH designations were created. So this app was really created to give users like you a view of the newly proposed EFH designations. So it's a really nice interactive tool. You can zoom in, you can turn layers on and off, you can even layer layers on top of each other, so it gives you a really nice chance anywhere you are with an internet connection to check out these new designations. So the app shows the designations, but it also shows the analysis that went into creating these proposed EFH layers. So the goal is to make the review process transparent and let users explore both the maps and the data that supports them. So on the left, I'll just give you a quick overview of what you see here. So the Take a Tour button. So this runs through the parts of the app, so it's a good spot if you're not sure, you can't remember what does what. That's a good place to go. The layer info. So the top part is a methodology. So the proposed EFH layer was created through several steps. All of these are in the app. You can see the bolded. The bolded text refers to actual layers that you see in the app. And then down below is a definition for each layer. So this is a good place to come back to if you have questions, if you want to kind of think more about how these layers were created. So the Mid-Atlantic and New England Fishery Management Councils work together on this EFH update, and because of that, this app includes layers for both councils. So the first drop-down lets you switch between the two of them, so Mid-Atlantic and New England Fishery Management Councils, both of those are here. And then when you select one, the species filter to show only species of that council. So here's the Mid-Atlantic managed species, so they're all in here, and they're separated into life stages, so adult, juvenile, eggs, and larvae. Occasionally, we don't have a ton of great data for all species, so some of those have a single layer for all life stages, so those are under the all category. But you should see all Mid-Atlantic managed species in here. So we'll leave this on Atlantic mackerel since it's already loaded. Below that, you'll see a list of inshore surveys. So there's kind of two parts that go into the proposed EFH. There's inshore occurrences, and then there's also models. And so the model is based off of mostly the NIMS bottom trawl survey, NEMAPS bottom trawl, Maine, New Hampshire inshore trawl, and the Massachusetts bottom trawl. So those four together make up the models. But we have a lot of estuaries and small bays, inlets, things like that. So we wanted to make sure we're covering those as much as possible. So we have this list here, which shows all of the inshore surveys that we used. If you're really curious about any of these surveys, you can click here. It takes you to the NERA Data Explorer, and it's a great visualization tool. It gives you a chance to really go deep into any of these surveys. You can look at individual years, seasons, time, any kind of time periods you can imagine. You can look at individual species across individual surveys or multiple surveys at once. So it's a really great tool to really take a deep dive into these surveys and understand what they're showing and what kind of data they collect. So that's the sidebar. That's basically everything you need to navigate the app. And then what you see on the right side is the map itself. And so different layers, you turn them on and off with these checkboxes. So our proposed EFH is turned on here. And I'll just give you a quick demo. Like I said, I've got Atlantic mackerel loaded in already, so we'll just start with that. So you see proposed EFH in blue here, and then you can also turn on the current EFH, that's in a darker blue, and so you get a chance to kind of turn those on and off. They stack on top of each other. You can see how the older designation compares to our newer designation. I'll now go through the different model layers. So Chris Hake is giving his own demo of how the model works, but I'll just show some of the products that we have in the app and kind of explain what they are. The first one is the model encounter probability. So this shows the likelihood of encountering this species on a survey. So it's 0 to 1 scale, with purple being the lowest encounter probability, 1 being the highest, and you can kind of see how that shows up here for Atlantic mackerel. So I think the idea is basically if you were to click on a certain point in space, what are your chances of finding Atlantic mackerel in that area? The next one is model density, and so this shows you the predicted number of individuals per square kilometer. So for Atlantic mackerel, the highest predicted areas are kind of in this Georges Bank area, kind of like near the shelf over here in New Jersey, and then there's this hotspot that you see here off of Providence, Rhode Island. The next layer that we have from the model here is model quantiles, and so this shows habitat suitability grouped into quantiles. So yellow is the highest and predictions, and blue is the lowest. And so you might be wondering, how are these model predictions used in the proposed EFH? So I'll give you a quick run through of that now. So we start with the model encounter probability. So we basically created a mask using this. So we took out any cells below 0.25 and removed them. So this is the entire domain, but imagine we remove any cells below 0.25, so that's kind of like any of the darker purple areas. And then that mask is applied to the density. So we're only keeping the highest encounter probabilities and then the densities. And then from that, then removing any cells below the 5th percentile. So what you essentially end up with is this model quantile layer. And so again, what that's showing you is areas that have both high encounter probability and high density, and those are categorized into 4 different classes. Essentially 0.25 and above are what we're using for our proposed EFH. So the top 75% is EFH. And so you might notice on here that the models kind of stop here in this kind of mid-North Carolina, maybe Cape Hatteras area, and they also don't extend up into like the estuary areas. So the models, like I said, are mostly focused off of NIMS and some of, I think, Massachusetts, Maine, New Hampshire, and NEMAPS, which runs along kind of the coast here, but they aren't really using any data that goes up into the estuaries for the models. And so that's why we wanted to also do an inshore analysis as well. So again, the inshore surveys are listed here. And so what we did for this is we started with kind of a concept of how we could really kind of include inshore areas in kind of a clean way. And so we ended up creating these estuary zones. And so the idea was basically, if a survey is surveying, let's just say in the Chesapeake Bay, they might survey here, just a little sparsely in these different areas. But just because they're not surveying kind of like in a continuous mesh, which would be a lot of effort and take a lot of resources, we wanted to kind of include like areas into our proposed EFH. And so we created these classes. So you have, based on salinity, marine, polyhaline, mixing, and tidal fresh. So purple is marine, green is polyhaline, blue is mixing, and orange is tidal fresh. And then we also use depth to create depth classes, so shallow, mid, and channel, which are kind of light to dark. And it creates these estuary zones. So you might have marine shallow, you might have polyhaline channel, and so it creates these classes of kind of light conditions. And then when we look at these inshore surveys, we can say, if we've seen this species in these conditions, we expect to see them in similar conditions. And so it allows us kind of a more inclusive way of including estuary areas. So how this works is, I'll turn on the inshore occurrences for Atlantic mackerel. So you see that in a range of 0.25 up to 1. Again, like the models, I removed anything below 0.25 occurrence. And so that for Atlantic mackerel, that's off the coast of New Jersey, some in Long Island, up in Maine. So that comes from these surveys. And then I said which of the estuary zones have occurrences in them. And I created this subset, so you can see those in blue there. And so these are the areas where we're saying if maybe the model isn't going far up into the estuaries, maybe it's not covering all these areas. We have this great data. Where else can we include into the model? So that creates our species estuary zone. So essentially, we just add our model quantile plus our estuary zone, combine those together, and you have your proposed EFH layer. And so just to go through this one more time, just to make sure it's clear. So model quantiles. So we're looking at everything above 0.25. So that's blue, green, and yellow. So if I turn this on, you can see that's not including any of the dark purple areas. And then we also have our species estuary zones. So that gets turned on as well. In this case, it looks like our estuary zones are all already within the model predictions. Maybe there's a little bit here at the end of Long Island that was beyond where the models were predicting. Oh, and we also added a 3 kilometer buffer in estuary areas just to give a little extra insurance that we're covering everything. So model quantiles above 0.25, inshore occurrences above 0.25 are combined together to create this proposed EFH. Let me just show one more species. So let's take a look at scup adult. So one way just to be sure that it's a little bit slow, but just to be sure it's changed, just make sure the species name appears up here. So again, we'll go through this. So we have our proposed EFH for scup adults, a current EFH, so you can kind of compare what was originally designated to what we're designating now. And then you can look at your inshore occurrences, so where is scup occurring in our inshore survey, so a lot of New Jersey, Long Island, but then also some down to below Virginia Beach, some small sparse spots up in Maine even, and then that creates our species zones, so those are getting picked up by our estuary zone analysis. And then same thing for models, so encounter probability kind of matches what we're seeing in the inshore surveys, so kind of southern areas. And then model density, again, it's kind of hard to see a little bit here, but you have some hot spots kind of in this Long Island area. And then model quantiles, so keeping the blue, green, and yellow above our 0.25 threshold, getting rid of the purple areas, adding in our species zones. There's a 3 kilometer buffer that's added to those. Combine those together and you get your proposed EFH. So I think that's everything that you'll see in this app. Again, like I said, you can switch to New England species if that's of interest. So there's a number of different species in New England already. We're still in the process of doing more New England species, but like I said, the mid-Atlantic species are all currently uploaded. We can look at one more. Maybe we'll look at Atlantic surf clam. So it's just a really nice way for you to kind of take a closer look at what we're getting from our models, what we're getting from the inshore analysis. You can zoom in, you can turn these on and off, layer them, compare to what the current EFH is. Just a great way to kind of see what we're proposing. So I think that's about it. If you have any questions about the application, feel free to reach out to me. Again, my name is Tori Kentner. My email is tkentner@mafmc.org, and Kentner is Kentner. So Kentner@mafmc.org, and I'm always at council meetings, so feel free to talk to me then too. All right, thanks.